Hey everyone, what's up? Welcome back to Subnet Zero. So in the previous video, we had learned about transmission media like copper, fiber optics, and wireless, right? But we also ended on the question that just because two devices are connected with a wire, do they always have successful communication? Not really. So for that, we will understand why Ethernet is important in this video. So without further ado, let's jump right in. Let me just clear up this side. Hold on, give me a minute. So connection is not always is equal to communication. Yeah, because let's say if computer A is speaking Japanese and computer B speaks English, and if they're connected with each other, they are connected, but can they like talk to each other and can they truly understand? Not really. Like if you and your colleague, let's say if your colleague speaks a different language than you, and if you're connected through a phone, you're technically connected, but you cannot communicate. So Ethernet fixes this communication aspect of it. Okay. I also realized one thing that in my previous videos, I have been using Excalidraw for makeshift diagrams, but that might not always be uh, scalable. So let's say if I want to expand the diagram to larger and larger components. It might not always be possible in Excalidraw and we lose the point of reference. So to fix that, I've started this draw IO. Yeah, this draw IO specifically is very useful when you want to like scale up the diagrams, if you want to make the diagrams more and more complex and keep a single point of reference. Yeah. So this, what you see, the cloud over here, you see is the internet. This, what you see over here is the router, and this pink circle that you see, this is the private network that we have referred in our previous videos and playlist. Okay. So let's zoom into this and let's understand how communication works when it comes to this. Okay. So you see over here, this is PC1. If some of you are watching through mobile, I'd recommend you to pause and then zoom in for better understanding if you are finding difficulty seeing, because this is the best way I could make it as mobile friendly as possible. Okay. And if you have a desktop, my recommendation would be to see it on a bigger screen, like your laptop or your desktop. Yeah. So this is PC1. This one is the full desktop. Yeah, the one I've encircled. Okay. It wants to send hello, this word hello, to PC2. Now, how would that work? Set of NIC, that is Network Interface Card. Okay, this. It is this green thing that you see, this green illustration that you see over here. That is what we call is this one. Let me just, yeah, this one. This is the Network Interface Card. It looks like this. You see this? So now don't look at the word card and then wonder what it is. It's basically a hardware device that is inbuilt into most computers. Okay. The most interesting part is what it does. Now we all know that data is converted into binary. Okay. But how the binary is packaged into a format which is understood by all devices. This is where what we are referring to as the Ethernet frame. Let's get into what that is, okay? So you see this boxes. So imagine, let's say if you have a Russian doll. Those Russian dolls where, first there's a big doll, once you open it, there's a small doll, once you open it, there's even a smaller doll. Yeah, those Russian dolls, what I'm talking about. Similarly, it's like a Russian box. So when you open a big box, there's a smaller box. When you open a smaller box, there's even a smaller box inside it. Okay. So first, let's explore the smallest box, the one in peach. Let's understand what it is about, and then we'll zoom out and we'll understand the blue and the brown box. Okay. So first, let's get into the peach box. So the peach box basically is where the word hello gets converted into binary. That's ones and zeros. This is like an illustration I have provided to you. It's not the exact binary, but you get the gist. So this is packaged into a pink box. Once it's packaged into a pink box, we seal it and we dump it in this blue box. In this blue box, first we have the addressing to the destination IP address. That is the PC2. Yeah. The IP address of the device of PC2. Then we have the from addressing. That's your own device. That's the IP address of your own device. Yeah. Together, this blue box is what we call as the payload. I really want you to drill this term into your mind because we will come across this term a lot in our future videos. Okay. So once this payload has been sealed into this blue box, we dump it in this box, brown box, which is the largest box. This largest box is what we call as the Ethernet frame. This is the terminology. Okay? And it has something called as frame check sequence, FCS. So basically, frame check sequence does nothing but just manage errors. Okay? If there is some interruption or some issues, frame check sequence ensures that there isn't any. Okay? Now, when it comes to the addressing, there is first to destination MAC address, that is here. Yeah. So now there's the destination MAC address, which is the MAC address of the PC you want to send it to. And then there's from MAC address, that is the MAC address of your device. Now, what is a MAC address? Let's get into that. Yeah. Yeah, let me just format this properly. Just hold on for a second. So MAC address is basically a 12-digit alphanumeric number. What do I mean by alphanumeric? I mean there is numbers and then there is alphabets, okay, from A to Z. It looks somewhat like this. This is what a MAC address looks like. It's always 12 digits and it's always alphanumeric, okay? That is the main identity of the device. Now, some of you would be thinking that when we already have the IP address of a device, why do we need a MAC address? Here is where it gets interesting. So, imagine if you're an employee in an organization, yeah? You have an employee ID, but let's say if you leave that organization and if you move to a newer organization, you have a different employee ID, yeah? However, what does not change is your name. So the MAC address is like a name. It's much more specific. It's much more targeted. It's a stronger version of identification of your own identification, yeah? Now, I know some people who are much more technically advanced will say that, MAC address can be changed by so-and-so complicated process. But right now, we are not getting into that. Right now, we are in the beginner stage and understanding this is a lot crucial, okay? So the MAC address of a device is like your name. Similarly, imagine your computer, okay? If your computer has not computer, let's say if you have a laptop, okay? And it has an IP address assigned to it, okay? A IP address of the device. So let's say if you change your building or you change your city or even if you change your country, the private IP address will change, yeah? But the MAC address of the device will never change, no matter what network you are in, no matter what country you are in, no matter what city or state or province, wherever you are, it is not going to change, yeah? So that is the functionality of MAC address. And again, MAC address is completely burned into this network interface card. You see this? So there is where the identification, the name of this device lies, okay? So once the network interface card has packaged this word hello into the Ethernet frame, okay, once it's packaged it properly, it sends it through this copper cable, okay, copper fiber cable. I've used this particular shade because that's what the copper shade is, okay, for ease of understanding. And of the PC2, once it reaches the PC2, before it reaches the network interface card of PC2, unpacks it, translates it, and then you will be able to get hello, okay, and vice versa. Make sense? So, in a nutshell, if you want to summarize Ethernet, let me go further down. If you want to summarize Ethernet, it can be divided into two parts, okay? One is the physical aspect of the Ethernet. The other is the framework or the standard aspect of the Ethernet, okay? Now, what do I mean by the physical and the standard part? In the physical part, we have copper cables, fiber optics, and its respective connectors, that is RJ45 and LCSC, okay? So when somebody says or somebody asks that they need the Ethernet cable, what they're referring to is the physical aspect of it. Make sense? Now, there's the framework and the standard, which includes the MAC addresses, the Ethernet frame, the packaging of it all, the payload. Yeah, let me add this one more. The payload and everything related to it, okay? Make sense? So this entire thing is what the Ethernet comprises of. Okay, makes sense? So essentially it's like a set of rules to ensure that, all the devices are compatible with communicating with each other. As simple as that. Okay? If you want to do further deep dive, that's completely up to you. I would recommend that you do because you'll learn a lot more. this, what I've demonstrated, is like a very watered down version of it's a very simplified, watered down version of the concept of Ethernet. Okay? Yeah. So for now, I'm only going to keep it till here. Okay. The reason why I'm because I want to prevent learners burnout and to prevent overwhelming of my students. Okay. So I hope this video was fun so far. If it did, consider liking and subscribing and sharing with anyone who might find this useful. Please hit the bell, as we have only scratched the surface so far and we'll be deep diving into the rabbit hole further. And yeah, thanks for watching everyone, and I'll see you in the next one. Bye.